Hi students, we're going to talk now about exponential functions. So that according to our textbook, you can see they'll take the form of f of x equals a to the b times b raised to the x power. That b is a base, but it could also be our Euler's number e raised to a power times a. So it just depends on the problem you're given. What we're going to start with is just solving these equations for x. But before we do so, I wanted to just show you on the graphic that you see on the left side here, you can see two graphs. You see a linear graph, which is labeled A, and that's just a very slow moving, barely increasing linear function. B is an exponential function. It's growing very quickly. Once you get beyond 6 in the horizontal axis, you can see that like between 8 and 10 how steep the graph is. So it looks very different than a linear function. Let's come back together now and let's solve our equations. Let me use yellow and let's solve this. 3 to the 3x minus 4 is equal to 3 to the 5th power. Now there's a property that we want to keep in mind, and that is if a base raised to some power n is given to you as equal to a base raised to some power m, notice that the bases must be the same on both sides. We can imply then, you can say then, n has to equal m. Bases are the same, you can equate the exponents, which is what we will do here. We have a base of 3 on both sides of this equation, so we'll just set 3x minus 4 equal to 5, add 4 to both sides, so we'll have 3x is equal to 9. Divide out that 3, and then we have that x is equal to 3. And let's see how it looks in the function. So kind of like a check here. Let's go ahead and do this. So I'm going to go back to my original function, 3 to the 3 times x. So I'm going to multiply it by my answer, 3. Now we know x is 3. Minus 4 is equal to 3 to the 5th power. Let's see if that's true. The left side and the right side should look the same if that is true. So since 9 minus 4 is equal to 5, this is indeed true. 3 to the 5th on the left side is equal to 3 to the 5th on the right side. And we have checked. Let's look at B now. So problem B says 3 to the x minus x squared is equal to 1 over 9 to the x. It's a little bit more complicated. So keep in mind, what are we looking for? We're looking to try to get both sides to have the same base. I'm going to, before I do anything, rewrite this in a more convenient form. Oops. I want to move that 9 to the x to the numerator. I don't want it to be in the denominator of this fraction. So it would become 9 to the minus x power, using our negative exponent rule that we've been using a lot in these videos. So I still don't see the same base. I have a base of 3 on the left side, a base of 9 on the right side. But isn't 3 squared 9? So I can express the right side as 3 squared raised to the negative x power. And then I will have, 3 to the x minus x squared is equal to 3 to the negative 2x, because using the power rule for exponents, when I have an exponent and a power, I just multiply them together. So now I have the same base on both sides of the equal sign. I'll set my exponents equal to each other. X minus x squared is equal to negative 2x. Let me go ahead and continue this. Let me erase this side and we'll bring this up to the top here so that we can continue and finish this problem. So to continue, we want to figure out how to solve this. Now be careful with this because it would be tempting to try to factor and try to divide. You're going to be losing solutions if you try to divide this out. What you want to do instead is bring all the terms over to one side of the equal sign. How do I know this? Because I see a squared term, which means it's a quadratic equation. So let's go ahead, since I have minus x squared here, and I'm going to show the work for this here. So I'm going to subtract x from both sides. And on the right side. And then I want to add x squared to both sides. Since it's a subtraction here, adding it will undo that subtraction. So I want to, as I said, add x squared to the left and add x squared to the right. So what happens here is it gets rid of both terms that are on the left side, leaving a 0 on the left side of the equal sign. Let's rewrite this so that it's a little bit more convenient. Just bringing the x squared to the front. And I have minus 2x minus x, so minus 3x. Now I want to, instead of dividing, I want to think about factoring. So what do these two terms have in common? They have an x. So I'm factoring out an x, and that leaves me with x minus 3. So that means I have two solutions, which is what I would expect from a quadratic equation, since it's degree 2. So I have just an x. Using the zero factor property, I set each one equal to 0, each factor. Because if the product of two, because they are numbers, they look like variables, but if you replaced x with a number, then these would be two numbers. The product of any two factors or numbers, if it's equal to 0, then it means one of them or both of them have to be 0. So what do? We set each one of these factors equal to 0. So we have two solutions here for this problem. Let's go ahead and erase here, and now I want to once again do a check to see if my solutions really do work. Let's see if I can just do my check up here. Okay, so let's check x equals 0 in the original equation right here. So 3, let me just use pink as my exponent. 3 to the 0 minus 0 squared, is that equal to 1 over 9 to the 0 power? Okay. So 0 minus 0 squared is just 0 minus 0, which is 0. What's 3 to the 0 power? It's not 0. It's equal to 1. So we have 1 on the left side of this equal sign, and 1 over 9 to the 0, any base raised to the 0 power is equal to 1. That's a property that we need to remember. So therefore, we'd have 1 divided by 1, which is 1. Well, x equals 0 is a good solution. That works for us. Let's now check x equals 3. Sometimes we do need to check them because sometimes they may be a possible solution, but they may not solve the equation at hand. So we once again want to replace x with 3. So we'll have 3 to the 3 minus 3 squared. Is that equal to 1 over 9 to the third power. So I erased and rewrote this. And let's get to where we were. So we have 3 to the negative 6 power is equal to 1 over 9 to the third power. Now, could those be the same? Well, let's think about it. The left side is 1 over 3 to the 6th. But remember how when we started solving this problem, we found that 1 over 9 to the x was written as 9 to the negative x, and also is the same thing as 3 to the negative 2x, because I can express 9 as 3 squared. So if that's the case, then this is going to be 1 over 3 to the second raised to the third power. 2 times 3 is 6. Bingo. We found that these are both the same. We have two great solutions for this problem, that x can be equal to 0 or x can be equal to 3. Bye, students.